Welcome to today's Explainer. Literally every single AEM development team I talk to right now is asking the exact same question. Can I just let an AI agent write my client libs? We're constantly hearing about how AI is revolutionizing coding, but, well, enterprise architecture is a totally different beast. So I decided to set up a high-stakes experiment. I took a real enterprise component and let an AI agent build the entire client lib setup from scratch. The folders, the categories, the dependencies, the whole shebang. Today we're going to review what it generated. And spoiler alert, some of it was genuinely good, but two of its choices would have absolutely broken production. Let's see exactly where the line is.
Okay, let's dive into this. We're going to treat this explainer like a suspenseful pull request review. Imagine a brand new junior developer just handed you a massive chunk of architecture, and it's your job to figure out if it's safe to merge. But in this case, that junior developer is a large language model. Can an AI agent actually be trusted with AEM Clientlibs?
To make this a fair test, we had to set some strict ground rules. I gave the AI a real component, a content teaser with an image, a heading, and a bit of JavaScript for a read more toggle. Its existing styles and scripts were basically dumped into one giant, messy, global client lib. You know the drill, classic enterprise technical debt. And the absolutely crucial rule of this experiment? No hand-holding. I gave it one single prompt and just let it run. This perfectly mirrors how developers are actually trying to use these AI tools out in the wild. We don't want to spend an hour prompt engineering, right? We want a quick fix.
Now, just to quickly level set, let's define what a client lib actually is, just so we're all completely grounded before we analyze the AI's code. If you're newer to AEM, a client lib is simply a specialized folder that the platform treats in a really unique way. Its primary job is to bundle your CSS and JavaScript together, but the magic, and honestly, the danger, is that it's entirely controlled by a few very specific AEM native properties.
There are 4 critical properties a client lib absolutely must get right. Number 1, categories. This is the name other code uses to actually load your library. Number 2, dependencies. This tells AEM, hey, load this other library before you load me. Number 3, embed. This is an instruction to physically merge another library's code directly into this one's output. And finally, number 4, allow proxy. This allows AEM to serve your files from a safe public path instead of exposing your highly sensitive internal application folder. Now, here's the terrifying part about these 4 properties. Getting them wrong doesn't cause a giant flashing syntax error. Instead, you just get a phone call from an angry content author 3 days later. You get silent runtime failures. You get duplicated code, exposed internal paths, or components that look totally fine to the public but completely break the authoring interface. That is the trap.
So, keeping those silent failures in mind, here is the exact prompt I gave the agent to fix our global client lib debt. Create a properly scoped client lib for this teaser component with correct categories and dependencies following AEM best practices. That's it. Like I said, zero handholding. Let's see what the agent brought back in its pull request.
Section 1. The wins. What the agent got right.
We're going to start with the positive, because credit where it is absolutely due. The AI had some legitimate successes here. The agent methodically nailed the mechanical setup. Step 1. The folder structure was perfect. It created a proper client library folder, split the CSS and JS into their correct subfiles, and perfectly wired up the text includes. Step 2, and honestly, this is a massive win. It gave the teaser its own dedicated category instead of dumping it back into the global pile. This means the code will only load when the teaser is actually on the page. That's a high-impact architectural decision that a lot of human teams fail to make. In step 3, it correctly added a dependency on the base utilities library so our shared helpers would load first. For all those mechanical parts, the structure, the scoping, the includes, the AI saved me a solid half hour of just tedious boilerplate work. I gotta admit, the scaffolding was genuinely cleaner than a lot of human-written client libs I've inherited over the years. But as we know, writing clean code is only half the battle in AEM.
Section 2. The trap. Mistake 1. The proxy problem.
All right, now for the privet. This is the part of the AI coding demo that nobody puts on YouTube. Let's drop the hammer on the first critical production-breaking mistake. The agent completely left out the allow proxy property. Without allow proxy, AEM serves your client lib straight from your internal app's path. On a published public-facing site, this dangerously exposes your internal application structure to literally anyone who simply opens their browser's network tab. On a secure enterprise project, no way around it. This is an outright security violation. The fix is incredibly simple, right? Set allow proxy to true, and AEM securely routes it through a safe path, etc., client libs. But the AI completely missed it.
So, the crucial point is this. The code ran perfectly. It rendered flawlessly on the screen. There were 0 console errors. But it was quietly leaking our internal architecture to the world. This is a massive blind spot for AI, because it relies on knowing exactly how AEM serves files at runtime, not on JavaScript or CSS syntax.
Section 3. The trap. Mistake 2. Embed versus dependency. Now this second mistake is a lot subtler, but significantly more expensive over time. The agent totally misunderstood the difference between embed and dependency. It used embed to pull in our shared base library. Remember, embed physically merges the code. That sounds harmless, right? Well, actually, that shared base library is also embedded by 3 other components on this exact same page, which means the exact same base CSS and JavaScript got shipped 4 times to the browser, once per component, resulting in a massive 4x page bloat. On a large, content-heavy enterprise page, that creates real, measurable performance issues.
The correct call here was to use dependency. Load the base once and let everything depend on that single copy. I really want everyone to lock in this axiomatic takeaway. Embed equals copy. Dependency equals share. The AI failed this test completely silently. Again, no errors whatsoever. It just made the page significantly heavier, which ironically defeats the entire purpose of scoping the client-lib in the first place.
Section 4. The new human-AI workflow.
So, where does this leave us? We've seen the brilliance of the scaffolding and the danger of those blind spots. The practical solution going forward is a strict division of labor. On the AI side of the ledger, let it do what it's genuinely good at, the mechanical tasks. Let it generate the scaffolding, the folders, the text includes, and the category naming. It is faster and often a lot cleaner at this than we are. But on the human side, you absolutely must rely on a developer for the critical AEM runtime decisions. A human must review every client lib to verify the proxy checks, evaluate the embed versus dependency logic, and ensure the code behaves correctly in author mode, not just on the published site.
And that really brings us to the central thesis of this entire explainer. The pattern across both of those mistakes was exactly the same. The agent writes clean code that simply does not understand AEM's runtime environment. And that specific runtime knowledge? Yeah, that is not getting automated away anytime soon. If anything, understanding how AEM actually behaves just became the single most valuable part of a developer's job. To put it simply, the agent makes you faster. It doesn't make you optional.
We've explored the incredible speed AI offers and the silent, structural traps it sets. It's a really powerful tool, but it requires a pilot who actually knows the terrain. So I want to turn this over to you. Have you let AI touch your client libs on an enterprise project yet? And more importantly, what broke silently? Reflect on your own workflow and see if you're falling into these runtime traps. Thanks for joining me on this explainer, and keep learning.